Hello friends. In the last video of scatterplot, we had seen how to detect relationship between two or more variables by using scatterplot and looking at the trend of scatterplot. But only obvious relationships can be detected easily by looking at the graph. In some cases, it is not possible to judge the relationship between two variables only looking at the graph. But the good thing is that we can comment about the relationship between these variables using statistics. Yes, I am going to explain the use of statistics in determination of relationship between these variables as well as to predict the response of one variable if you know the value of another variable. So let's begin. Correlation. The term correlation is a combination of two words. Co means together and relation means connection between the two quantities. Correlation is when, at the time of study of two variables, a unit change in one variable is reacted by an equivalent change in another variable, directly or indirectly. Or else, the variables are said to be uncorrelated when the movement in one variable does not show any movement in another variable in a specific direction. It is a statistical technique which represents the strength of connection between the pairs of variables. Correlation can be positive or negative. When the two variables move in the same direction, that is, an increase in one variable will result in corresponding increase in another variable and vice versa, then the variables are considered to be positively correlated. For example, profit and investment. On the contrary, when the two variables move in the different direction in such a way that an increase in one variable will result in decrease in another variable and vice versa, this situation is known as negative correlation. For example, price and demand of a product. Correlation analysis. The degree of association is measured by a correlation coefficient denoted by R. It is sometimes called as Pearson's correlation coefficient after its originator and is a measure of linear association. If a curved line is needed to express the relationship, other and more complicated measures of correlation must be used. The correlation coefficient is measured on a scale that varies from +1 through 0 to -1. Complete correlation between two variables is expressed by either +1 or -1. When one variable increases as the other increases, the correlation is positive. When one decreases as the other increases, it is negative. Complete absence of correlation is represented by 0. This figure gives some graphical representations of correlation. Calculating correlation coefficient. This coefficient is easily calculated by using Microsoft Excel and Minitab very easily. Correlation coefficient by Excel. There are two simple methods to calculate the correlation coefficient in Excel. Method 1. Let's take an example of temperature of the day versus ice cream sale. To determine the correlation between these two variables, use a function correl. Type the function correl and select first variable column and apply comma. After that, select second variable column and press enter. We will get the value of correlation coefficient as 0.96. It means there is a strong relationship between variables. Method 2. Let's continue with the same example. To determine relationship between these two variables, use the analysis toolpack add-in in Excel to quickly generate the correlation coefficients between multiple variables. We need to execute the following steps. Step 1. On the Data tab in the Analysis group, click Data Analysis. Step 2. Select Correlation and click OK. Step 3. Select the range A1 to B13 as an input range. Check labels in the first row and select Output range anywhere in the sheet or New Worksheet option and click OK. We will get the final results as below. It is showing same value of correlation coefficient, that is 0.96. Indicates strong relationship between variables. Regression. We have seen that correlation describes the strength of an association between two variables and is completely symmetrical. The correlation between A and B is same as that of the correlation between B and A. However, if the two variables are related, it means that when one changes by a certain amount, the other changes on an average by a certain amount. If y represents the dependent variable and x independent variable, This relationship is described as regression of y on x. The relationship can be represented by a simple equation called as regression equation. In this context, regression simply means that the average value of y is a function of x, that is, it changes with x. The regression equation representing how much y changes with any given change of x can be used to construct a regression line on a scatter diagram. And in the simplest case, this is assumed to be a straight line. I am not going to further details as we can easily found it by using simple softwares like Microsoft Excel. Let's continue with the same example of temperature of the day and the ice cream sale to understand the regression analysis and how to interpret the summary output. Step 1. On the Data tab in the Analysis group, click the Data Analysis. Step 2. Select Regression and click OK. Select the y range, that is B1 to B13. This is a predictable variable, also called as dependent variable. Step 4. Select the x range A1 to A13. These are the explanatory variable, also called as independent variables. These columns must be adjacent to each other. Check labels. Click in the output range box and select cell A16. You can select anywhere in the sheet as well as in the separate worksheet. Check residual and click OK. Excel produces the following summary output. Rounded it to the 3 decimal places. R square. R square equals 0.917, which is a very good fit. 92% of the variation in ice cream sale is explained by the temperature of the day. The closer to 1, the better the regression line feeds the data. Now let's see the significance F and P values. To check if your results are reliable, that is statistically significant, look at significance F value 0.000. If this value is less than 0.05, you are okay. If significance F is greater than 0.05, it's probably better to stop using this set of independent variables. Delete a variable with a high P value, that is greater than 0.05, and rerun the regression until significance F drops below 0.05. All P values be below 0.05. In our example, this is the case, 0.015 and 0.000. Coefficients. The regression line is y is equal to ice cream sale, which is equal to minus 159.474 plus 30.088 into temperature of the day. In other words, for each unit increase in temperature, ice cream sale increases by 30.088 units. This is a valuable information. You can also use these coefficients to do a forecast. Residuals. The residuals show you how far away the actual data points are from the predicted data points using the equation. For example, the first data points equals 215. Using this equation, the predicted data points equals minus 159.474 plus 30.088 into 14.2, which is equal to 267.773, giving a residual of 267.773 minus 215, which is equal to minus 52.773. We can easily see in the diagram. Conclusion. With the above discussion, it is evident that there is a big difference between these two mathematical concepts, although these two are studied together. Correlation is used when the researchers wants to know that whether the variables are under study are correlated or not. If yes, then what is the strength of their association? In regression analysis, a functional relationship between two variables is established so as to make the future projections on events. Please do not forget to like the video if you have found it useful. Add your valuable comments and suggestions regarding this video as well as the channel. Share this video with all your friends and families who need it and subscribe my channel. I will share similar useful information with you which will help you to improve your knowledge and skills in future. To get notifications of new videos on my channel, please go to YouTube settings, notifications, learn and apply and click on the bell icon. And finally, thank you for watching.